So we're going to use a couple of examples from the exercises in your textbook at the end of Chapter 3. And if you don't already have a calculator handy, you should have one available. You can pause the video and grab a calculator, and you might want to have a sheet of paper as well, just to make any additional notes. So this is question number 24 from section 3.2. And some college students did a project where they asked other students to do a Skittles taste test and see if they could identify, being blindfolded, of the flavor of Skittles by tasting it. So they were told what the 5 possible flavors were, and they were given a single candy to put in their mouth, and then they were asked which flavor they had. So 154 students were tested, and 78 gave the correct answer. So we are going to find and interpret a 95% confidence interval. Notice that this is for the proportion of all healthy students. Notice the all. So again, we are creating an interval that is giving us plausible values for the parameter, which applies to the entire population, as opposed to the statistic, which only applies to the sample. So we should go through a couple preliminaries: the observational units, the variable, and the variable type. And if you want to pause the video and try this out for yourself, I highly recommend it. The observational units are the 154 students that were tested. The variable, I would say, is whether they identified, S is for student, that's a capital S for student, whether the student identified the correct flavor of Skittles. And that is a categorical variable. Categories are yes and no. And of course, that is also binary. Now, in order to create the confidence interval, first of all, it's important that we identified the variable type. So if you want to look, if you have this either printed out or on another computer, you can look above to see for a categorical variable how we create the confidence interval with the 2SD method. So notice that since the confidence level is 95%, we can use the 2SD method. So we need to know the p-hat value, and it has to be a decimal. So p-hat is our statistic, that is the sample proportion of successes. In this case, 78 out of 154. And again, I encourage you to do the math on your own calculator. You should get 0.506, so a little bit more than half the students correctly identified the flavor. And since we're doing a 95% confidence interval, so CI will be my abbreviation for confidence interval. That means our multiplier is 2. And so again, based on the formulas that were given up above, these are the formulas in number 2 under categorical variable. The 95% confidence interval is the statistic p-hat plus or minus the multiplier 2 times the square root of p-hat times 1 minus p-hat all over n. So what we're going to do is plug the pieces in and work our way down. And again, I strongly recommend that you have a calculator handy and you calculate these things as we go and make sure that you can get the correct answers. So our statistic p-hat, we calculated as 0.506. So we now have to plug that in everywhere there's a p-hat in this formula. And then n, the sample size, is 154. So now I invite you to pause the video and do the calculation of the square root and see if you can come up with the correct answer. That would be 0.506 plus or minus 2 times, and when you put all that in your calculator, you should get 0.040 to 3 decimal places, which means our interval will be 0.506 plus or minus 2 times 0.04 is 0.08. And when we get it down to this point, so we have now our statistic plus or minus the margin of error, which I will abbreviate MOE, margin of error. Now is where we split into two pieces, so that's what the plus or minus means. So we are going to do 0.506 minus 0.08, and then we are going to separately do 0.506 plus 0.08. So that's what the plus or minus means. So again, pause the video, put this in your own calculator. When you do 0.506 minus 0.08, you should get 0.426. And when you do 0.506 plus 0.08, you should get 0.586. And we put a comma in between and put parentheses around that, and that is our 95% confidence interval. Now, we should also interpret the confidence interval, and we're going to do several of these, but you'll kind of start to see the pattern in the interpretation. We usually start it with we are blank percent confident, depending on the confidence level, in this case 95% confident. And then we identify what the parameter is, the proportion of all healthy students. So again, we are estimating the parameter that applies to the whole population. All is really important here. Healthy students that could correctly identify a Skittles flavor blindly. And I just want to point out that we were given a description of that parameter in the statement of the question. If you're lucky enough to have that, then you can just copy it into your interpretation. So now comes the time where we're actually putting the confidence limits together. So this proportion, and I'm going to write it as a percentage, is between 42.6% and 58.6%. So notice that I converted the decimals in my confidence interval into percentages by multiplying each by 100 or moving the decimal 2 places to the right, because the interpretation we want to be sort of a real world kind of thing, and most people understand percentages pretty well. Now keep in mind, we took a sample of 154 students. We found the proportion of the sample that correctly identified a flavor. Based on that, we can create this confidence interval that estimates what the proportion would be for the whole population of all healthy students. So what might the parameter value be? Well, plausible values are somewhere between 42.6% and 58.6%. Now we are also going to find a theory-based interval. So I'm going to go to the applets and look at the theory-based inference applet. And because my variable is categorical, I'm in the one proportion scenario, which is the default, but that's where we would find scenario. And I'm going to put the n value in. The sample size was 154. Now, if you were given a count, I would put the count in. 78 out of the 154 students correctly identified the flavor. Once you click out of that, then the sample p-hat comes in automatically. If you're not given a count and you only have the sample p-hat to go by, then you can go ahead and put the sample p-hat in and the count will come in automatically. Now, you can click calculate. That just gives you a little bar graph that shows you what proportion of the sample were successes and what proportion were failures. Success here is correctly identifying the flavor, and failure is not correctly identifying the flavor. But what we're interested in is the confidence interval. And notice that the confidence level default is 95%. That's the most common confidence level we'll have. And the calculation is automatically done as soon as we check the confidence interval box. So we don't really have to click on calculate. And the confidence interval is given as 0.4275 up to 0.5855. So I'm going to write that down. We only ever will use the computer to get the theory-based confidence interval, 0.4275 up to 0.5855. And you can compare that to what we got using the 2SD method and notice that they're pretty close to each other. And we should check the validity conditions. We really should have done that first. Are the validity conditions met to be able to use a theory-based method? So again, if you look up above at the theory-based table, for a categorical variable, we have to have at least 10 successes and 10 failures in the sample. So the conditions are met. We have, in fact, 78 successes. And we could do a quick calculation to figure out how many failures. Let's see, would that be 76? I believe so. So it's better to identify how many successes and failures you have rather than just saying, yes, we have at least 10 of each. It's better to say how many you have of each so we know that you understand what it is you're finding.